Alright, today guys we're going to talk about the binary number system. Um, but to talk about the binary number system, we first have to talk about the decimal number system. The decimal number system, when we talk about that, I like to start with the prefix, which is deci. So what does deci mean? Well, typically, like if you think like a decagon or decimal, we get the point and 10. So these are base 10 numbers, which means that there are 10 numbers in this number system. So a base 10 number system has 10 numbers. The numbers in our decimal number system are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there's 10 different numbers that we use in the decimal system. We use this decimal system to represent numbers in our everyday life, and it works pretty well. But when we start talking about digital electronics, we can't use the decimal number system anymore because digital electronics only understand two states, which is on and off, right? So for digital electronics, those things can only turn on or off. So we use what we call the binary number system. So we use the binary number system to represent that. Bi means 2. So in the binary number system, the only numbers you have are 0 and 1. And typically 0 represents off, and 1 would represent on. So to enable you to kind of decode and turn these numbers back and forth so that you can use them, so you can design digital systems, we have to have a way to convert the numbers back and forth, and that's what I'm going to start to show you today. The first way, there's two ways to do it really, to convert a decimal number or a base 10 number into a binary number. And the first way is pretty easy, but what we have to consider first are our multiples of 2. So 2 to the 0 power, 2 to the first power, 2 to the second power, 2 to the third power, 2 to the fourth power. Sorry. 2 to the fifth power, 2 to the sixth power, right? And so on and so forth. So what that is 2 to the 0 power is 1, 2, 4, 8, 16, 32, 64, right? And it keeps going forever kind of thing. So what we want to look at here is if I have the number 75 and we want to convert that into the binary number system, what we would first have to do is find the number in our base 2's here that is closest but not bigger. So in this case, it would be 64. So we would take 64, and then we're going to take 75 minus 64, and you're left with 11. And the number that is closest to 11 but not over is 8. So then we take 11 minus 8, and that equals 3. So then our next number would be, don't forget to put the 8 up here. So our next number would be 2. So then we have 3 minus 2, which equals 1. So we don't want to forget to put the 2 up here. And then we have 1 left. So 1 minus 1 is 0. Means we're just about there. So we've got all of that. We don't want to forget to put the 1. So if we now add those numbers up top, 64 plus 8 is 72, plus 2 is 74, plus 1 is 75. So 75 and this are equal to each other, which means that we've done a good job here. So now what we have to do to convert the number 75 into binary is we take a look at all the ones that we've got these red squares over. This will turn into a 1. We didn't use 32, so that's a 0. We didn't use 16, so that's a 0. We used 8, so that's a 1. Didn't use 4, so that's a 0. We didn't use 2, so that's a 1. And we did use 2, so that's a 1. And then we did use 1, so that's another 1. So 75 is base 10, so that's our decimal number system. And 75 represented our binary number system is 1, 0, 0, 1, 0, 1, 1. Okay? So now I want to try a harder one with you guys. I want you to do this one yourself. So let's try 435. So I want you to pause the video here, try this one on your own, and then come back and we'll solve it together. All right, so first I want to take my base 2's here. So I got 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, 2 to 4 is 16, 2 to 5 is 32, 2 to the 6 is 64, 2 to the 7 is 128, 2 to the 8 is 256, and if we do 2 to the 9, we get 512, which is bigger than 435, so we don't need that one. We're not going to worry about that guy. So now the biggest number that is still smaller than 435 would be 256. So we'll put our 256 up here. Circle that guy. Right? So our 435 minus 256 is equal to 179. Our next biggest one would be 128. Right? So plus 128 here. So 179 minus 128 is equal to 51. Our next one would be 32, because 64 is too big. So up here we'd put 32. So 51 minus 32 is equal to 19. So our next one would be 16. So 19 minus 16 is equal to 3. So our next one would be 2 plus 2. So 3 minus 2 is equal to 1. So our next one would be 1. And then 1 minus 1 is 0. So put our plus 1 up here. So now if you were to add 256 plus 128 plus 32 plus 16 plus 2 plus 1, you would get 435. So now what we have to do is we go through and we use that one, so that's a 1. We use this one, so it's a 1. Didn't use that one, so it's a 0. Use this one, it's a 1. We use this one, it's a 1. Didn't use this one, so it's a 0. We didn't use this one, so it's a 0. We used this one, we used this one. Okay, so 435 in binary is 1101110. 0, 0, 1, 1. All right, so earlier in this video, I mentioned that there are two different ways to solve for the binary when starting with a decimal. So I'm going to use our example of 75 again to show you the other way. So what you're going to do to solve for this, and what we got last time was 1, 0, 0, 1, 0, 1, 1. So we're going to see if we get that same number again using this other method. Okay, so this other method just involves us dividing by 2. But instead of putting fractions every time we divide by 2, we're going to use the remainder system. So if you take 75 divided by 2, it equals 37.5. So we're going to write 37 remainder 1. If you take 37 and you divide that by 2, it's going to equal 18.5 or 18 remainder 1. You take 18 divided by 2, gives you 9 even or 9 remainder 0. You take 9 divided by 2, gives you 4.5 or 4 remainder 1. Take 4 divided by 2, gives you 2 or 2 remainder 0. 2 divided by 2 is going to equal 1 or 1 remainder 0. And then 1 divided by 2 is equal to 0.5 or 0 remainder 1. So now that we've done all of that, got to the bottom, we've got what we call the most significant bit, or MSB, and we've got our least significant bit, or LSB. Okay, and we use those because the way we're going to take these numbers is we go from the most significant bit to our least significant bit, and then we write out our remainders. So we use the remainders to get, if we go in order from most significant to least significant, we get 1, 0, 0, 1, 0, 1, 1, which is the same as what we got using the other method. All right, so now I want you guys to try to do 435 yourself and see if you get the same answer that we got earlier in the video. All right, so 435 divided by 2 equals 217, remainder 1. 217 divided by 2 equals 108, remainder 1. 108 divided by 2 equals 54, remainder 0. 54 divided by 2 equals 27, remainder 0. 27 divided by 2 equals 13, remainder 1. 13 divided by 2 equals 6, remainder 1. 6 divided by 2 equals 3, remainder 0. 3 divided by 2 equals 1, remainder 1. 1 divided by 2 equals 0, remainder 1. So we have our most significant bit and our least significant bit, and we go this way. So we would get 1, 1, 0, 1, 1, 0, 0, 1, 1. And that, if you remember from earlier in the video, is exactly the same. So we did a good job. We got that complete, and that is how you turn decimal numbers or base 10 into binary numbers or base 2.